Hello viewers, let us continue on this concept of trigonometric ratios and identities. Now we want to be able to solve trigonometric equations. To solve trigonometric equations means you look for the value of a known angle that satisfies that trigonometric equation fully. And the value of that angle can appear more than once. Using a circle, the unit circle that we drew before, this is what you're going to have. This is y-axis and this is x-axis. There was a right-angled triangle here with an acute angle, theta, the angle made between the x-axis and this line. So we know that angles at a point add up to 360. From here to here it is 90, here to here is 180, 270, 360. Angles are measured anti-clockwise from the positive x-axis. They are measured this way. So if we draw the same triangle in the second quadrant, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. So we want to draw the same right-angled triangle in the second quadrant. Now, if we bring this similar angle here, the second possible value of the angle that satisfies that equation is going to be this angle from here up to here. And that value is found by angles on a straight line, that is 180 minus theta. So in the second quadrant, the value of the angle is going to be 180 minus theta. In the third quadrant, if we draw the same right-angled triangle, what happens? And we bring this same angle here, theta. So in the third quadrant, the value of the angle is going to be this way, up to there. So it's going to be 180 plus this value, 180 plus theta. Then lastly, in the fourth quadrant, if we draw the same right-angled triangle, we bring the same theta here. The value of the angle is going to be this angle here, up to that point. So that means the entire revolution, which is 360 minus theta, the remaining space. So 360 minus theta. So in the first quadrant it is theta. In the second quadrant it is 180 minus theta. In the third quadrant it is 180 plus theta. In the fourth quadrant it is 360 minus theta. That is how you find all possible values that satisfy a given trigonometric equation. Another thing that we need to know is this. Very important. Using the same circle. Like that. Y-axis and x-axis. So we have the right-angled triangle here with angle theta. We have said that sine of theta is given by change in y value from the previous video that we did, change in y values, or even before we do that, using integers. We know that from this origin, from the origin towards this direction, all the values of x are usually positive. From here upwards, all the values of y are usually positive. From here, this direction, from here this way, all these values are negative, values of x. Then from this point downwards, all these values of y are negative. That's very crucial. So let us focus on the first quadrant, second quadrant, third quadrant, fourth quadrant. In the first quadrant, we said that sine of angle theta is given by change in y values from the previous videos we did. Cosine of theta is given by change in x values from the previous videos we did. I told you cosine of theta is change in x values. Now, since we are in the first quadrant, y is positive, x values are positive. So cosine value is positive, sine value is positive. What about tangent? I also remember I told you that tangent is given by change in y or change in x, that sine of theta divided by cosine of theta. Still they are positive because we are using this positive axis and this positive axis in the first quadrant. Now what happens when you come this way? Second quadrant, theta. Now, sine of theta is still given by change in y values, and the y value is still positive. Y value is still positive. Cosine of theta is given by change in x values, and you see x axis is now negative. So cosine of theta is going to be negative x because we are here. Tangent of theta is given by sine, which is y, and y is positive, over cosine. Cosine is x, and here x axis is negative, so you are going to have negative x here. So in this quadrant, second quadrant, the value of sine is going to be positive value, but the value of sine is a negative value. The value of tangent is also a negative value because of this. Let us proceed to the third quadrant. We draw the same right angle triangle here. Bring angle theta here. The same formula in the third quadrant. Sine of theta is given by change in y. And what is the value of change in y? Here the value of y in the third quadrant, sorry, I'm supposed to draw it this way. The change in y value is negative here. So that's going to be negative y. We're using this. Cosine of theta is changing x values, and the x values are in this side of negative. So we're going to have negative x. Tangent of theta is sine over cosine, and that is negative y divided by negative x, which gives you positive y over x. So that means that in the third quadrant, sine is negative, cosine is negative, but tangent is positive. Hope we are moving together. In the fourth quadrant, lastly, draw the right angle triangle here, bring theta here. Sine is supposed to be changing y values. And what is the y value here? We are talking about y-axis, we are here, so the y-axis is negative. Cosine of theta is supposed to be changing x values, and what is the x value here? Which axis are we going to use? We are going to use this axis, which is positive x, because we are here. Positive x. Then tangent of theta is sine divided by cosine. That means negative y divided by positive x. That gives you an overall negative value. So that means in this quadrant, the fourth quadrant, the value of sine is negative, the value of cosine is positive, the value of tangent is negative. So generally, having established this, what do we know generally? Let us generalize that finding. Y-axis and x-axis. In the first quadrant, we just have theta here, and we have seen that sine, cosine, and tangent are positive. So here we say all are positive. Letter A stands for all. Trigonometric ratios. All ratios are positive. In the second quadrant, we saw that it is only sine that is positive. You can rewind the video to check what I've just done. We have established that it is only sine which is positive. So S, only sine. In the third quadrant, we have established that only tangent is positive. T, only tangent. Only tangent is positive. I'm using the word only to specify, to be specific. There is nothing else that is positive apart from sine. There's nothing else that is positive apart from tangent. And then in the fourth quadrant, we have established that only cosine is positive. Only cosine is positive. These are positive ratios. Positive ratios. Positive ratios in the first quadrant, all are positive. In the second quadrant, only sine is positive. In the third quadrant, only tangent is positive. In the fourth quadrant, only cosine is positive. Hope that one is helpful.